And in today's video, we're going to go over question number 5, longest palindromic string. So let's get into it. So the question is asking us to return the longest palindromic string. And really, there's not much to it, as long as you know what a palindrome is. It's basically just, so in this case, it's going to be a string that reads backwards and forwards the same. So for example, race car is a palindrome. It reads race car both forwards and backwards. If we spell backwards, R-A-C-E-C-A-R, race car again. So let's get into the examples. So let's say 1, because it can be digits and English letters, so C, G, 2, G, 7. The longest palindromic string would be G2G. So basically what we need to see, I think I'm already starting to get an observation, right, is that we need to see when there's a duplicate, then we need to see if it's a palindromic string in between, if that makes sense. So we can make another example. Let's say race cat. Let's say race cat. And the longest palindromic string will be A-C-A-C-A. And so here, what we do is we're at A, and then we look for the next A kind of duplicate, so long as there is one. And I think for every letter we'd have to look at it. So if I say R, A, C, E, C, T, T, for example, the answer would be C, E, C. But then we have to think, okay, so we're looking for the A on the other side, we didn't get that. We need to look for the C on the other side, so we get this 3 right here. Check when there's a duplicate. And evaluate. If this string is a palindrome. Probably something like string, if string equals reverse string, then it's going to be a palindrome. So we each have to check that. So what I'm gonna say is, I have a theory. What if we start from the middle of the string? So let's think of an example, another example. Let's say x equals, let's say race car. Right, so we start at the middle, which would be E, and then we have an I variable, so we go here and here. So we say C equals C. So then we want to say, is this string here a palindrome? So E is a palindrome. A palindrome. So then CEC, we get CEC, and then we could keep going out, and then get race car eventually. Let's think about an example like this, where it's so if we were to do here, the answer is going to be RAR, right? But we start in the middle, then we get R equals B, A equals Z, and R equals D, so that actually doesn't work, unless you're just trying to find if a whole string was a palindrome. If you're trying to find that the whole string is a palindrome, that would be effective. But we are trying to find a substring, if possible. Or if there is no whole string, then we want to try and find the substring, which will at most, or at least be 1, because the length is always 1. So let's think, what could we do? I think we just need to go forward in the list. So let's think of if we had race. Let's say we had something like this, so the answer is going to be TT. If we start from the front, could we do a O(n) squared solution, where it's something like we iterate through and we find if there's an R, then we want to get the string in between. Something like that. And see if that's a palindrome by checking it's reversed. Or do we want to say, is there a quicker way than O(n) squared? So when we get to T eventually, then it'll just say TT. Return that, I guess, but is there a faster way than O(n) squared? Is there a different idea, different approach? What if we thought instead about, I'm not sure. I'm trying to look at the examples. So if we have BABAD, because we also need to think of, let's think of this example. So let's say we had BACAZ, a CAZ, for example, and we started at B. I feel like O(n) squared is maybe best. I'm trying to think of a different way. So if we started at B and we didn't find a B, then fine, then we go on to A. Right, so we go to A. Oops, I'll just say go to A like so, and then we find A again. So we have A, and then we evaluate the substring in between. So we would just say I plus and then I minus. Or if it's just a substring, I think if we're using list indexing in Python, then we could just say up to I value. I feel like that would make sense, probably the O(n) squared. If we came into an example like so, like say it was AA, then if we're at A and then we find A again, well then the palindrome is just going to be, it's going to be length of 0, right, if you're using indexing. But in theory, what we could do is we could also just use the whole string and see if it's a palindrome. So let's try and do that using an O(n) squared solution. Let's try and lay out some small steps. So I'll just say set up O(n) squared loop. If the first, or if the ith element, actually it can be like this, it can be like I equals 0, I is less than length, and then j equals I plus 1, j is less than length. Technically this could be like length minus 1, I think, like so, because we always want to go to the next element. So if the ith element equals jth element, get substring. Actually, still the second step. So get substring, reverse, and see if it's equal to the substring. And then actually we want to say, we want to define a string at the start. So we want to say, because we were going to want to replace that if the length is greater than, like for example, let's say, I'm going to say define max string if, so if the length of substring is greater than max string, which is, or we can just say len max string. Like so. Then we just want to say, what do we want to say? Oh yes, then we want to say, then, actually this is still in the if statement, so we're just going to say, then max string equals substring, and then return substring. So let's do that. So let's go into our code window. Let's get started. Let's do the solution with Python today. Been a lot of Python. I need to go back to Java probably. But okay, let's do step 1. Define max string and set up a 1 squared loop. Actually, let's say step 0 is the base case. Oops. Base case. If s, if len s equals 1, return s. And then we're going to say define max string and set up the nested loop. Max string. And then for I in range len s. I think we go -1 here, just for one less iteration. For j in range I plus 1 len s. Yeah. Because if we don't find any palindromes, let's say we have, instead of this, let's say we have A, B, C, D, then in theory, the longest palindromic string can be any of these characters. So actually, we're just gonna say, actually, we can make a check at the end. So if the ith element equals jth element, oops, get the substring and see if it's palindromic. So let's say if si is sj, then we want to say that the substring is going, or actually what we want to do is we want to say if they're equal, then find out, then get that substring, and only if the length is actually greater than the max string length, then only we want to reverse it and see if it's a palindrome. So we're going to say get the substring. So we're just going to say sub equals s I think we could say j plus 1. Apologies if you heard that. So this actually needs to be, can this be j plus 1? Or is j correct or j plus 1? Oh no, it's j plus 1. Because if it's at the end of the list, then it'll include that last element. So that's what we want. So then we're going to say if len sub greater than len max string. Okay, so only if the substring length is greater than max string length, we want to reverse. So we're going to say if sub equals reverse sub, then we are going to say max string equals sub, and I hope it doesn't actually. Nah, that should be fine. So we're going to say that, and then just return the substring, the max string. Return max string. So let's see what happens. Oops. It's not good. I want to see if it gets into the here, so if the elements match. So let's print the sub. Let's see what happens. So we have BAB and ABA. Okay, fantastic. Reversed. Am I using reversed correctly? I'll reverse a string. I can use this. Let's try that. I forget that was there's that special thing, so let's say sub colon -1. Nice. So I guess reversed was like weird or something. Alright, let's test the test case that we had come up with with the number. So that was 1B, C, G, 2G, 7. So let's see if that works. Okay, nice. Let's get rid of sub. Let's try and submit, and let's see what happens. It seems like it's taking a long time. That's not good. Uh-oh. Oh, what? AC. Oh, I forgot to do the check. So we want to say, we just want to say a check, do a check to see if, I'm just going to say, if there were no palindromes, return. I'm just going to say S0. So if len max string, oh my goodness, equals 0, return S0. First index, oops, wait. Let me try just like AC. Okay, fantastic. And let's try and submit now. This time complexity I think is gonna bite me, perhaps. Okay, it's not great. I really want to see a different solution though, so let's take a look at that. Oops. All right. Wow, they're up to 8,000. Oh my goodness. Let's see a really low time. Start equals max I minus lenres -1. So at least 0. Okay, that maybe that's a start index. Temp equals, oh, wait. So if it doesn't match, then the temp should be equal to left plus plus. Oh, this is like putting the left index 1 to the right, or incrementing a left index. And so instead of, wait, oh shoot, I lost it. Oh no, I lost it. Shoot, I shouldn't have done that. That was a really good solution, I actually understood it. Now I can't find it. I think it was like, I don't know, let's take a look at this one. So, oh, this seems to be the one actually. So, S equals start, okay. Start I plus 1, right. So for I in range len s, start equals max. So it's at least 0. Okay, fine. Temp equals the start. I plus 1. Hmm. So the end is I plus 1, so we're including the ith element. We're getting the start. So that's 0 minus lenres minus 1. I'm just confused how they get this as well. And then let's see. So they reverse to see if the string is valid. Otherwise, temp equals. Okay, and then 2 minutes. And if the temp is, so if it's reversible, then revert it to the previous. It's a little confusing. I might try and look at that later. That'd be pretty helpful. But anyways, we were able to solve the problem today. And yeah, I'm proud of, the medium climb so far. They only keep going. All right. See you later. Thanks for watching. Be sure to like, subscribe, and comment your favorite thing about the video or how I can improve my algorithmic skills.